How's it going, everybody? This is the next lesson that has to do with permutations. This is permutations when we have repeated objects or identical objects. So we have to treat it in a bit of a different way whenever we have identical objects. So we have this formula here where if we have n sets of things, but in that n there are a things that are identical, or you could have A things and B things, or you could have A, B, and C things that are identical. What we do is when we calculate the number of permutations, we calculate it by doing the total factorial, and then we have to divide out each individual thing that's repeating the factorial of those as well. So for example, if we have the letters here that spell the word Twitter, how many words can we make altogether? Well, we have 7 letters. Okay, but the thing is, this T and this T and this T are the same thing. So we have 3 T's. So wherever we put them, if I were to switch this T and this T around, it would still spell the word Twitter. Same if I change these 2 T's around, it still spells Twitter. So these are, they're the same thing. So wherever we put them in the word, wherever they like change places, it's not going to make a difference. So using this formula, we have 7 factorial different arrangements for the letters. But then because we have 3 T's, we're going to divide that by 3 factorial because that's going to take out those kind of extra arrangements of the T's. So when you do this calculation, I don't have a calculator here. I'll just pull up my calculator here quickly. So we have 7 factorial divided by 3 factorial. We get 840 possible words or arrangements. Okay, and again, depending on, there could be just 1 or 2 repeating things, or there could be multiple repeating things. It just really depends. Example number 2 says we're making 8-digit codes, and we have these 8 digits here. So in total, we have 8 digits, but we have 2 2s, and we have 3 7s. Okay, so when we do this calculation, the total number of permutations is 8 factorial, but then we want to divide out each of the individual repeating parts. So divided by 2 factorial times 3 factorial. Now, when you are doing this on a calculator, again, it depends what kind of calculator you are using. But my advice to you would be to do this bottom calculation first, or if you're doing it all in one step, put it in brackets like so. Okay, so I'm going to do 8 factorial divided by, then I'll open up my brackets here, 2 factorial times 3 factorial, close my brackets, gives me 3,360, codes. Okay, so again, this is a very basic application, but the most common thing would be rearranging letters or rearranging numbers or something like that. Now there is another type of example here which involves pathways. So in this case, we're going from A to B, but we can only move right and we can only move down. So you might say, like, how is this a repeating permutation question? But if we look at these paths here, so this is right, 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 and this is down, down, down. So in this case, we have 3 rights and we have 3 downs. Okay, so in total, we're making 3 moves to the right, 3 moves down. So there are 6 moves in total, where 3 of them are right and 3 of them are down. So this would be 6 factorial divided by 3 factorial, which is, get rid of that, 6 factorial divided by 3 3 factorial times 3 factorial? The answer is 20 ways. Now, there is a way that you can solve this problem without using permutations with repeating letters, but it involves a little bit of logic, a little bit of thinking. So what we can do is we can count the number of ways for each of the possible, I guess, like steps, if we take it one step at a time. So for example, going from A, just going one block to the right, there's only one way that we can do that. If we start at A and we go down this way, there's only one way that we can do that. We can only go straight down. And then if we consider this point right here, how many ways can we get to this point? Well, we can go this way and then down, or we can go down and then to the right. So there are 2 ways to get to that point. Now there's going to be a pattern that emerges here. The more we go to the right, there's still only one way to do that because there's no way that we can cycle through all of the blocks. We can only go straight right, and similarly we can only go straight down. Okay, so these are all, there's only one way to get to this point, there's only one way to get to this point. But now to get to the points that are in the middle, all we do is we add the number of possibilities for each of the, I guess, adjacent corners. So if we want to get to this point here, well, I could go this way down, I could go down and then to the right, or I can kind of zigzag through here. So in this case, there are 3 ways that we can get to this point. But if you look at the adjacent numbers, there's one way to get here and 2 ways to get here. So if we add those together, there are 3 possible ways. Okay, so this is like kind of a little trick. Same thing to get to this point here. There's one way to get here and 2 ways to get here. So there are 3 possible ways to get here. And then we just keep adding adjacent corners. So 3 plus 3 is 6. 3 plus 1 is 4. 4 plus 6 is 10. 3 plus 1 here is 4. 4 plus 6 is 10. And 10 plus 10 gives me 20. So we ended up with the same answer, whether we use the permutation method or the counting method. Now, obviously, the counting method is a lot more work involved, but just know that that is an alternate way to get this particular answer. Now, I'm going to throw one more example in here because I believe, yes, this is the last example. So now what happens if we have a grid like this? I'm just going to draw it out here. It's just a 3 by 3 grid. And again, we want to go from A to B, but what happens if we want to make a stop at C along the way? Okay, so this is a very common question that I have seen asked in provincial exams in the past. Usually it's not something as simple as just going on a grid. There's like some kind of stop that is along the way. So how do we calculate the number of ways that we go from A to B, but we have to hit C along the way? And the way that we do this is we kind of break it down into 2 separate problems. So we know that we need to hit C. So if we go straight down to the bottom, we're never going to hit C. We can only go straight across to B. So what we can do is we can basically eliminate this pathway right here. Same thing, if I start at A and I go all the way to the right, and I can only go right and down, there's no way that I can get back to this B area. So this whole section also gets eliminated. So what this turns into is a problem that looks like this, where we have a grid like that. Those are my possibilities to get from A to C. I mean, plus all the middle pathways. And then we have to go from C to B. So basically, it's like taking a grid like this and splitting it into 2 smaller grids. And now what we can do is we can calculate each of these grids separately and then multiply our answers to get the total number of ways. So if we're going from A to C, we have to make 2 right moves and we have to make 2 down moves. So that's going to be 4 moves altogether, so 4 factorial, divided by 2 factorial, 2 factorial. So we're going to do 4 factorial divided by 2 factorial times 2 factorial. And we get 6 ways that you can go from A to C. And I mean, 6 was our number that was already on the grid, so that is correct. Now we want to go from C to B. So we're starting here at C. We're making 2 moves. One of them is a right move, one of them is a down move. Doesn't matter which order you do them in. So this is 2 factorial divided by 1 factorial, 1 factorial, which is 2 possible ways. Now, the reason why we multiply these numbers together is because we want to go from A to C, and then, and this is the key word, and from C to B. And one of the things that we talked about earlier in this unit is when we are considering the case for and, that is when we multiply our things together. So that's why we multiply 6 times 2, which is 12 possible ways. I put a box around the wrong thing. There are 12 possible ways to go from A to B while also making a stop at C along the way. So again, this is a pretty common provincial exam question. I mean, not common, it doesn't show up on every exam, but this is more likely to show up on an exam than just a simple grid from A to B.